Hey everyone, welcome back. Let us continue with pattern 11. In this video, we will be solving all the bordered star patterns. Let me just show you one example. This is our pattern 11. This is nothing but bordered triangle. As always, let us fill out an empty spaces. We are done with converting the pattern into matrix. Let me just write down the indices. Here, we will be starting the index from 1. And input for this pattern is nothing but 5. Let us frame the table for this. Row representing I, prefixed spaces. The key point to note here is that for every row, we will be considering the starting index of star and then the ending index of star. It is kind of a bus where it won't be stopping anywhere in between the start and end. But only the last bus stops at every station between the start and end. These are the two key points here. Let us frame the table now. We need starting star index, ending star index. We know we won't be counting the suffixed spaces. For row 1, we have prefixed 4 spaces and the starting star index is nothing but 5 and ending index is also 5. For row 2, 3 spaces, 4, 6. For row 3, 2 spaces, third index and then 7th index. For row 4, 1 space, second index and then 8th index. For row 5, 0 spaces, index 1 as the start index, index 9 is the end index. Now we got the table. We need to find out a logic for starting star index and ending star index. I'll also tell you why we won't be framing a spaces logic here. Logic star start index star end index. By looking at the numbers, we can directly say that the numbers are getting decreased here from n to 1. In such cases, what we can do is we can have a bigger number. What is the bigger number here? N, right? And then subtract something from it so that we can get the numbers. We can do I plus 1. Let us check whether this holds good for all the numbers or not. For row 1, 5 minus 1, 4, 4 plus 1, 5. This is holding good. 4 minus 2, 3, 3 plus 1, 4. 4 minus 3, 2, 2 plus 1, 3. 5 minus 4, 1, 1 plus 1, 2. 5 minus 5, 0. 0 plus 1, 1. Yes, all the numbers are holding good here. So that we can consider the logic for star start index as n minus I plus 1. Moving on to star end index, here the pattern is the numbers are getting increased from n. How can we get these numbers? Can we use the same method over here? We can have n for row 1, we have 5. How can we get 5 over here? Since the values are getting increased, we can add the value of I to it. Let us check whether this holds good for first row or not. N is 5, 5 plus 1, 6. But we need 5. Let us check whether this holds good for second row or not. N is 5, 5 plus 2, 7. But we need 6. What we can do here is we can directly subtract the value of 1 from it to get the numbers correctly. Let us check whether this logic holds good for all the numbers or not. N plus I, 5 plus 1, 6, 6 minus 1, 5. 5 plus 2, 7, 7 minus 1, 6. 5 plus 3, 8, 8 minus 1, 7. 9, 9 minus 1, 8. 10, 10 minus 1, 9. Yes, all the numbers are holding good for this logic, so that we can consider this for end index, star end index. Let us write down an algorithm for this. I missed one more point here. For pattern 11, we need to run the row loop from 1 to 5. We are good. This starts from 1 to n instead of 0 to n. But the column loop is running from 1 to 9. How can we get this 9? Pretty straightforward. 2 into n minus 1. That's it. N is 5, 10 minus 1, which is 9. So we can run the column loop from 1 to 2 into n minus 1. I hope this point is clear. For row starts from 1, goes till n, row plus plus. Since we are starting the row loop from 1, we need to have equals condition here. And then the column loop, which again starts from 1, goes till 2 into n minus 1, column plus plus. Here the logic changes. Since we need to print the stars at a particular index, we can have an if condition checking whether the index is equal to our logic or not. If column equals n minus I plus 1, or column equals n plus I is nothing but row minus 1. We need to have one more condition here mentioning that if row equals n, we need to print the stars at every index. If you observe in the pattern, at row 5, we have stars at every index. So we can have the same condition in the if condition. Print star without new line character. If these conditions are not true, we can directly print spaces. That's it. It's pretty simple and straightforward. After completing a row, we need a new line. That's it. We are done with the pattern. Let us go back to IntelliJ and let us try to code it. Public static void pattern 11 takes in n as input parameters. Start for loop for row which starts from 1, goes till n and row plus plus. Inner for loop for column starts from 1, goes till 2 into n minus 1, gets incremented every iteration. If column equals n minus row plus 1 or column equals n plus row minus 1 or row equals n, print stars without new line characters. If the index are not matched with the logic, print spaces without new line characters. That's it. After every row, we need a new line character. We are done with pattern 11. Let me just call that out here. Pattern 11 of 5. I'm running the program. Yep, it's printing the expected result. I hope so far the things are clear. That's it for this video. But before closing the video, I would like to give few more things here. I want you all to try out pattern 12. Just try out the inverse of this pattern. This is the inverse of pattern 11. Just try this out by yourself. You can definitely do it. I want you all to try out pattern 13, which is nothing but capital letter W. Input for this pattern is nothing but 5. For both of 12 and 13, it's 5. I hope you all can do these two patterns. With that hope, I'm closing this video. Thank you all for watching. See you in the next one.